We, for our last lecture, we have seen the biomolecules, and especially we have learned three of the molecules, or three of the types of molecules that we have seen, that lipids, protein, and carbohydrate, right? And all of these molecules are quite long chain molecules. Carbohydrate, still they are organic, that means carbon and hydrogen there, and oxygen, of course. So organic actually is carbon and hydrogen is there, the backbone is carbon and hydrogen, and then other elements like oxygen, nitrogen, hydrogen, phosphorus. So all these things can be in different arrangement, but they should produce especially a longer chain. So that is the biomolecules. And these are the work examples that has been given. There is not much to talk today, actually. It is very much simple things that we have discussed, and not much thing for me to explain for today, because what we have already discussed in the lecture slides, that explains a lot almost. Okay, so I'm directly going to the testing questions, and before these, the worked examples are there. It's clear, and I hope that you have all gone through all this. So that self-test, sorry. So self-testing question, the first one, it says that what type of reaction and bond would join a glycerol? Let me take the pens. Okay, so glycerol and fatty acids, right? So quickly, what is a glycerol? Can anybody tell me what is a glycerol? What do we call a glycerol? Anyone? Glycerol is 1, 2, 3. Three hydroxy propane, right? Or propane triol. Let me clear my throat first. Wait a minute. 1, 2, 3 triol, right? Propane triol. So this is a glycerol. And another thing, just for your information, glycerol tastes sweet, okay, and it is thicker because, of course, the bigger molecule, so it is much thicker than water. And I mean, when I'm talking about, when I'm saying thicker, it means in compared to water is thicker, and you can find it in the pharmacy. You can find it in pharmacy, and most interestingly, you can find it if you have ever taken a cough syrup. Most probably there are some glycerol. So to some extent, it does not do anything good or bad to our body. It just goes out as it is. And that is the good thing about the fats, that part of it does not stay in my body. It goes out, but it doesn't mean that you have to take the fat too much. Yeah, I mean, not too much, but yeah. Okay, so glycerol and fatty acid, what is the bond between them? Glycerol and fatty acid. So when they bond together, glycerol and fatty acid, they will, where the bondage will occur, for them, this OH group, right, from this 1, 2, 3 propane triol plus fatty acid is a carboxylic acid, long chain carboxylic acid, COOH. Of course, this carbon is attached to another CH2, CH2, CH2 like that. So this hydroxyl and hydrogen, they will go out and it will produce water. So this is what type of reaction when the water goes out? Can anyone tell me what type of reaction it is when the water goes out? No, it is a condensation reaction, right? So because the water is going out, they becoming condensed, and they form an ester linkage. Ester linkage because there is a CO here. Sorry, CH. I delete it now. Okay, so there is a CH here, CH2, and this side, and then again CCAOH the same way. So this is, they will produce a ester linkage. By this way, they are producing an ester linkage. So the condensation and ester linkage will be the correct answer. Which of the statements about the substance of chemical formula CH3, CH2, 10 of the CH2 is here in the chain and COOH is incorrect? So it is classified as a saturated fatty acid. Is it a saturated fatty acid? That means will it have a double bond or not? How many carbon and hydrogen is there? So we see 1, 10, and 1. So there is 10 here, plus 1 here, plus 1 here. So there are 12 carbon, right? There are 12 carbon. And if it has to be saturated, it will be CnH twice N plus 2. Twice N plus 2, it will be the saturated. But this, since there is oxygen here, this 2 will be replaced by 1. So if CnH twice N plus 1, then it is a saturated fatty acid. So we see that there are 3 here and 2 times 10, that means 20. So 23, 24, right? So it is, let's say C12 and H24. H24. It was supposed to be H25, right? Then it would be saturated. But since there is 1 less hydrogen, that means there should be 1 unsaturation is there. So this statement is not correct. It is not a saturated fatty acid. B says the carboxylic group present causes the molecule to be hydrophobic. Wait. Which of the statement about this substance of chemical formula is incorrect? Oh, what is the incorrect one? That means all of them are correct, one is incorrect. Let me check again. 3, 23, 24 plus oxygen 2. So this is a saturated actually, because there is 2 oxygen. Yeah, there are 2 oxygen, not 1. So C12H24 is a saturated hydrocarbon. Actually, it is telling us saturated because 2 oxygen, not 1 oxygen. So 2 oxygen is there. So it is saturated hydrocarbon. So we need to read the question properly, otherwise it will be we'll give the wrong answer. So this is correct, and this A will not be the answer for this, right? A is correct. It's a saturated hydrocarbon. B says the carboxylic group present causes the molecule to be hydrophobic, water fearing. But we see that carboxylic group COOH, right? Because of their high oxygen and hydrogen and carboxylic group is always water loving, or it dissolves in water, just like acetic acid or ethanoic acid. So when ethanoic acid, acetic acid is there, it will be water loving, it will be dissolved in water. It is not a hydrophobic. Hydrophobic means like water and oil, they do not mix with water, right? Oil. So water, oil is a hydrophobic group. But this is a fatty acid anyway. But it is fatty acid itself, when it is not attached to this glycerol, is a hydrophilic. That means it dissolves in water, or it is possible that it will be dissolved in water. So it is not the correct answer. It is incorrect. Sorry, it should be the correct answer. It should be the correct answer. It is the incorrect one. This is a carboxyl group. Yes, we know. And the substance derived from certain fats and oils. Yeah, this is true as well. So this is correct. This is correct. Only this B is the incorrect one. Question number 3 says one of the major constituents of palm oil is palmitic acid, which has the formula CH3, CH2, 14 of CH2, and then COOH. When this acid is reacted with potassium hydroxide, the main constituent of oil and soap is produced. What will be the other product of the reaction? So let's say that we are mixing potassium hydroxide, OH, right? So potassium hydroxide, if we react with this, then where the reaction will occur? I mean, where does it seem that the water reaction will occur? This hydrogen will go, and this hydroxyl from potassium hydroxide will leave, and it is water is being produced. So in a way, it is being condensed. Then this potassium is going to attach to this carbon, actually to this carbon, but in this side. So it will look like COOK, right? So this is a potassium salt of this fatty acid. And this is the main ingredient of our soap that cleans the dirt from our clothes or hand. This is the potassium palmitate, potassium stearate. These are the things that is the main ingredient of the soap. And the other of all the things, the fragrance, the advertisement comes out that it is gentle on your skin, the fragrance is good, moisturizing, all those things are added up. So those are not main ingredient of the soap. Okay, so this is a soap, and then what else will be the other products that will be produced? Now we have just seen that hydroxyl and water, hydrogen is going out, so water will be the main product from there. Question number 4 says, which molecule is always produced when triglycerides undergo hydrolysis? So when it is hydrolyzed, the triglyceride, that means the fatty acids are attached to the glycerol. The fatty acids are attached to the glycerol, that is the triglyceride. And if hydrolysis means the water is a reactant, or water is being broken to two parts and going to attach this triglyceride when they are broken up, right? So once again, those who did not pay attention to the lecture, I'm drawing it for you. So this is a triglycerol, H2. This is H2, and triglyceride is here will be CO. And then it is a CH2. For this, let's say we put in the palmitic acid here. So CH2 will be 14 CH2. I don't need to repeat all CH2, just put the value here. It will be okay, and then CH3 here. So consider here is the same thing happening. Here is the same thing there. Consider here is the same thing, the palmitate. So if I put water here, water, of course there are three molecules, right? This is number 1. Let me take a different, I don't know why I cannot. Okay, so this is one fatty acid part, there should be another fatty acid part, there should be another fatty acid part. So 1, 2, 3. 3 fatty acids will take, one fatty acid will take one water. Okay, one water molecule. So 3 fatty acid will take 3 fatty acids, 3 water molecules. And then what will happen is water will be broken into H and OH part in this way. So OH will go to this COO and OH is going to get to this carbon, right? If it happens, they will be broken from okay, I don't know how can I change it. Okay, so they will be broken from this part, right? On left side it is a glycerol, on right side there will be 3 fatty acids. If there are same, just like here, there are 3 all palmitic acid, 1, 2, 3. So there will be 3 palmitic acid, CH. I'm not going to do it, but 3 palmitic CH2 14, right? So it will be 3 palmitic acid on this side if there are all 3 here. But if there are 3 different fatty acids that are attached to this glycerol, then there will be 3 different fatty acids produced. But only one molecule of glycerol will be produced because this OH is here, OH is here, OH is here. So the one molecule of glycerol will be produced, and glycerol is this. So C is the correct answer. Question number 5, it says that unsaturated fatty acids contain. Is there any question so far? No. Okay, unsaturated fatty acids contain one or more carbon-carbon double bonds. These can undergo an addition reaction with hydrogen using a nickel catalyst. Which of the following represents the molecular formula of fatty acid that would react with hydrogen in this way in a mole ratio of 1:1? That means this question is saying that since we know that unsaturated fatty acids, when there is a carbon-carbon double bond, one carbon-carbon double bond, then 2 hydrogen will come here and attach to this one hydrogen atom will come here, another hydrogen atom will come here, and of course one bond is being broken, only one is staying there, or one is left bond and another bond is broken. So if it is out of these 4, which one is capable of having one double bond? Okay, one double, because 1:1 ratio. So one double bond, hydrogen 1:1 ratio means one hydrogen is 2 atoms, right? Hydrogen gas, 1 hydrogen, 2 atoms. So one hydrogen molecule will react. So which of them has only one double bond? Can we find which of them will have one double bond? It is C18H34. Because again, CnH twice N, right? CnH twice N. So in this case, 1836 is supposed to be 36, but it is 34. That means it is implying that there should be one double bond here in this C. And the rest, this is already saturated. There is no double bond, and this A and B, there is saturated, but there is more than one bond. This is 2 double bond. This is 3 double bonds here. So yeah, the C is only the one that will take one hydrogen atom. Question number 6 says, when starch is formed from glucose, the condensation reaction that occurs involves starch from glucose. Oh yeah, so so glucose is a single unit, right? C6H12O6. C6H12O6. This is a single unit, and then we can write in this way oxygen is here, and CH2OH is there. OH is there, and then OH, hydrogen OH, hydrogen OH, in this way. So when there is a condensation reaction is going on, it will be on this hydroxyl, on this carbon hydroxyl, not with this oxygen, not with this oxygen, not here, not here, on this hydroxyl group. So another one will come of this glucose will come, and then that's hydrogen, like it will have a hydrogen here. That hydrogen from that molecule will come and react with this hydroxyl. So this is this reaction is involved with two hydroxyl functional group. Two hydroxyl functional group from the other the neighboring to glucose molecule, two hydroxyl functional group will come together, the water molecule will go out, they become condensed or infused together, right? So two hydroxyl functional group will be involved in this reaction. Question number 7 says the molecular formula of glucose is this: if a disaccharide is produced from two glucose monomers, what will be the molecular weight? Disaccharide, that means two glucose will be there. So when two glucose will be there, we can just add up 180 again, 180. So it will be 360, right? Two saccharide, one glucose is there, and then disaccharide means two glucose atoms or molecule side by side attaching together. So the mass will be also added up to the one which was in the previously. What was the mass? That is 180. So another 180 will be added up because there are now two of them. But the thing is, it is tempting that 360 is supposed to be, but the thing is, when there are two saccharide is attaching together, there is a condensation reaction. One water molecule is going out. So 18, one molecule of water has a mass of 18, right? H2O. H2O, O oxygen is 16 plus 2 hydrogen 2, 18. So 360 minus 18 is supposed to be 342. But now another thing is, what will be the bondage between them, right? So bondage is always the ester linkage. It's not an ester linkage anymore because it is a glucose. It is what do you call it? Carbohydrate now. It is not a lipid. It is not lipid. It is a carbohydrate. So it is a glycosidic bondage. It is a glycosidic bondage, and let me draw it here quickly. So let's say this is a, okay, you know, this is a hexagonal. So one water hydrogen, I mean oxygen is another oxygen. Let's say I'm just, yeah. So this oxygen, and between two carbon, there is an oxygen bond, oxygen molecule between two carbons. So this is a ether bondage, or it can also call glycosidic. So this is the correct answer. C is the correct answer. What type of reaction describes the polymerization of glucose into cellulose? Polymerization of glucose into cellulose. So what type of reaction describes the polymerization of glucose into cellulose? So glucose is, again, one is the monosaccharide. This is the monosaccharide, and then there are polymerization means many glucose is coming together and attaching together. So this is, again, the water molecule is going out. although water molecule is going out, it is not ester linkage, it is a glycosidic linkage, and still since water is going out is a condensation reaction. It is not addition reaction. Addition reaction is when addition reaction is like this, that let's say there is a two carbon-carbon double bond, one double bond is being broken and two hydrogen are attached to it, right? So this is an addition. The hydrogen is just being added on top of what was there. Hydrolysis reaction is when there is like hydrogen, water is being broken down to hydrogen and hydroxyl, and these two hydrogen and hydroxyl is being added or incorporated into the reactant. So water is a reactant here. It is doing something actively. So this is a hydrolysis reaction. And substitution reaction, we already have seen that if we remove this hydrogen and add a chlorine, let's say chlorine or another hydroxyl here, that will be substitution. So chlorine or hydroxyl or any other thing will replace this hydrogen. That will be substitution reaction. So all these things are not happening here. Only the condensation water is going out from this reaction. So it's a condensation reaction. Question number 9. Which of the following compounds in the is the building block monomer of carbohydrate? Out of these, what should be in the carbohydrate? Means carbohydrate has a certain type of molecules, right? And it should be able to produce a glycosidic bondage as well. And it does not have a carboxylic group. But for this case, we see that there's a carboxylic group here, there's a carboxylic group here, there's a carboxylic. No, this is an ester linkage here. Oh, no, it's carboxylic group as well. Sorry, this is carboxylic group because this is carbon here. This corner means there is a carbon here, so it's a carboxylic. So we don't need all these things. So B is the correct answer. Question 10 says, when a protein such as insulin is formed, the condensation reaction that occurs involves protein insulin is formed. The condensation reaction occurs. What will have in each? A carboxylic functional group and an amino functional group, two hydroxyl functional group, or a hydroxyl functional group and a carboxyl functional group, a hydroxyl functional group and an amino functional group. So let's say start from there, a hydroxyl functional group and an amino functional group. It is not protein. Hydroxyl and amino, it's not protein, it is something else is producing, but it is not going to produce any protein, right? So for protein, that we know it is an amino acid. The building block is the amino acid. What is an amino acid? Is COOH. It is an acidic group is there. This is an acidic group, COOH. And then there will be something, and then there must be an amino group, NH2, right? There should be an NH2 group there. So there can be other things, CH2, and then it can be another carbon chain, doesn't matter, but as long as there is a NH2 and COOH, that should be the building block or monomers for producing protein. So it should have an amino functional group and a carboxylic functional group for this case. Two hydroxyl functional group that will be is good for formation of starch, right? For starch, they react two hydroxyl group there together. One hydroxyl functional group, another carboxyl functional. This is a lipid is produced from there that we see lipid, fatty acid carboxylic group, and then glycerol is OH or hydroxyl functional group. So it's a lipid. So this cannot be the answer for this. So A is the correct answer. 11 says in living things, glycine can react with other amino acid to form polypeptides and protein. Glycine can react with other amino acids. So glycine itself an amino acid, and it is reacting with amino acid to form polypeptides and proteins, right? So this reaction between 2 or 3 more amino acid from a polypeptide to form a polypeptide is classified as, so will it be an esterification reaction or a hydrolysis reaction? Esterification reaction when there is an ester bondage, right? COOH, this is the ester bondage will be produced. I think we have talked a lot about this, so I'm not going to talk too much. So this is ester bondage, hydrolysis already. So it's not addition. No, it's not an addition. They do not just add up. When there is an addition reaction, it does not form. I mean, the one is going to be vanished in another thing. So this is not an addition reaction. It's a condensation. So they condensed together. They become more fortified together. This is the condensation reaction is occurring because water molecule will go out. So this is the condensation reaction will occur between glycine, any amino acid. Okay. Oh, hold on just a second. Okay, so question number 12. Examine the following protein segments. Okay, so now you see that there are many different type of proteins. I don't know all the names of the different segments of the protein, but I understand that they are protein. How do I understand? I'm telling you. So if there are different protein, I mean, together and they're bonding together, there's making a peptide, polypeptide, I mean, smaller protein. When they are making a big together, that becomes a long chain. That's a peptide. So there are, I mean, itself, it is a new protein. Itself, it is another protein, and this protein is being formed by this condensation reaction, COOH. It was a COOH and NH group, right? Do you understand? From looking at it, this CO come from COOH, right? OH, and of course this carbon is bonded to this CH2, and this NH group is coming from NH2 amino group. So when there is a reaction, this hydrogen and this hydroxyl go out, produce water, and then they become infused together. This is the condensation reaction. So this is how the condensation, the previous question is, I mean, it explains the previous question. So now when the condensation reaction goes on in this way, right? So it is how many, the question is saying that how many different amino acids are there? How many different amino acids are there? In one amino acid, there should be one amino group, NH2 group, and one COOH group. So this is a peptide bondage. This is another peptide bondage. This is another peptide bondage. So how many? 1, 2, 3, 4, 5. 5 peptide bondage is here. But how many different types of amino acids are here? This is one amino acid, NHCO, NHCH3, one amino acid, because it has amino group and carboxylic group. You know, if we do the hydrolysis, if we break it down in presence of water, if we put water and then it breaks down, it will produce one This is one protein, molecule. And then this is another one. If I break it, it will produce another one, number 2, because this 1 and 2 is very much different, right? This is one carbon, here is many carbon chain. This is another one. It will produce another carbon, protein segment. And this is another one. So this is number 3. This is number 4. And you see that all 1, 2, 3, 4 are different looking. It looks different. Their orientation, the number of carbons, the number of other elements in there are different. But this one is number 1 as well. This is 1 and this one is the same thing. And this is another same thing, which is number 2. So 1 and 2, 1, 2, 3, 4, they arrange in, you can say sequentially, or maybe not following the sequence. So it will be, so this is a long peptide and it has 4 different types of amino acids. You can make another, if you just arrange like this is one type, let's say this is A type amino protein. You can produce B just by rearranging these 1, 2, 3, 4 in different places. So you can make, it will be different protein. So there are 4 different proteins are there. Question 13, it says that which of the following compounds in a monomer that can be used to form protein? Again, very simple question. This is carbohydrate that we know that's carbon and hydrogen. There is nothing else there, and one ether bondage in between them in the same structure. So this is a carbohydrate. For this case, we see that there is a carboxylic group. Here is the carboxylic group. Here is the amino group. So this is okay for producing a protein. But for this case, there is a carboxylic group. Here is the carboxylic group, but there is no amino group. This is the amino group, right? But there is no amino group. So this cannot be used. And you know, this is the glycerol. It does not have any other thing. And so it is not it cannot produce a protein as well. Digest fat. What is the other name of fats and oils? Lipid, right? We have seen it last class, LIPID, lipid. So lipid is being broken down by lipase. Okay, so there is a quite similarity. If you can remember in that way, that lipid is broken down by lipase, and protein is by protease, and disaccharides by maltase. So different type of enzymes, they work different type of things. The lipase will not go to break down this carbohydrate, never. They cannot do that. Okay, question number 15. Which of the following statements about enzymes are correct? Enzymes are protein. Yes, they are protein. Enzymes increase the rate of biochemical reaction. Yes. To what extent? 10 to even 10 power 20 times. Can you imagine? You put 20 zeros behind 10. How many billion? Will it be a trillion? 100 trillion. Anyway, so it increases the chemical reaction rate. And these things are happening in our biological bodies. Enzymes increase the equilibrium constant of biochemical reaction. Equilibrium constant. No, it doesn't. So it cannot increase the equilibrium constant. Equilibrium constant is constant, right? It is already a constant. So how can you increase it? Yeah, so it can shift the equilibrium, like Larshortley's principle. It can shift to the right, to the reaction side, that is, reaction is occurring, but the equilibrium constant is staying there at constant, because it is not using any temperature or pressure unless you use the temperature or pressure. Okay, so 1 and 2 is the correct answer. B. Right. Is there any questions so far? No. Right. So maybe I'll give you some time to think if you have any question, or if you want to ask me. I mean, if you want me to go through some other of the questions. And by this time, I will clear my throat, and I think I need some tea to clear my throat. Yeah. So maybe 2 minutes. No. 2. I mean 5 minutes. I'm coming back. Hello, I'm here again. So now we will be discussing about the past exam questions, and the past exam question says that the following structures represent some biologically important molecules. So what are what? Which are what actually? Which structures represent the monomers used to form disaccharide? So it has to be a monosaccharide, only then it is able to be produced. I mean, it will be able to produce a disaccharide. So I can see that this is a fats and oil. No, I should not put T. These are fats and oils as glycerol. So B is a good choice for disaccharide. So this is again is capable of producing disaccharide by just being added up. So D is already a disaccharide, right? D is already a disaccharide. Which, question number B says, which structures contain a peptide linkage? If it has to be a peptide linkage, that means it is a protein already. Only a protein will have a peptide linkage. And this is, I can see that CONH, this is a peptide linkage here. So G is the correct answer for peptide linkage. C says, which structure represent a structured triglyceride? A saturated triglyceride. So for this case, I see that this is a triglyceride, and this is saturated fatty acids there. So this is A is the saturated triglyceride is there. D, which structure contain, okay, so I should write here B and H for this, B and H, and glyceride is A. Oh, sorry. E and H is here. Which structure contain a peptide linkage is G. Which structure represent a saturated triglyceride? It is A. And question number D say, which structures contain both amine and carboxy functional group? Amine and functional carboxy functional group, which structure does it? Is there any? It does not have a amine and carboxy. It's not amine and carboxy. Is there any amine and carboxy? Is there any amine and carboxy? For this G, it is already peptide. It does not have any carboxy group now. It had before they become polypeptide. It had, but they got condensed, and the carboxyl group is no more there. So for this case, I see NH2 here and COOH group is here. So this is carboxy and peptide group, both are there, so it should be F. Which which is side product common to all condensation reaction? Of course, I. It's quite easy question, right? That's what I'm saying. The questions are quite easy. Olive oil, which is a mixture of compounds, is commonly known in cooking. Triglycerides are compounds in olive oil. Triglyceride formed from carboxylic acid and another oil. Name the other molecule that is structured. So triglycerides are from carboxylic acid and another molecule. So another molecule, the other molecule is the glycerol. Glycerol. Right, that 1, 2, 3 propane 1, 2, 3 triol. Okay, either one is okay. Propane. So structure formula of carboxylic acid, oleic acid is shown below. You have to draw a structure. So when if this type of question is there, so you have to draw the structure like this. So this is a triglycerol, and there is this chain is coming here. So from this end, CO and CH2 7 and CH double bond CH and so on. So you have to draw the whole thing here. And of course there are CH2 here. So full structure you have to, all this you have to draw. Only then you get the full 2 marks if this type of questions are there. All the same things, I'm not going through all. So question number C says high performance liquid chromatography using a non-polar stationary phase. Now recall your spectroscopy that we learned in week 4, I think week 4 or week 5. Chromatography. So similar thing, which using a non-polar stationary phase was used to separate 2 glycerides in a sample of olive oil. The chromatogram obtained is shown below. All right, so state the meaning of the retention time. What is a retention time? Do you still, do we still remember what is the retention time? So retention time is it is coming out at 12 minutes, right? This is the minute. It's 12 minutes. Let's say it's 11.5 minutes, and this is let's say it's 13 or 14 minutes. It's coming out, right? So which one having the highest retention time? Triglyceride 2, right? It is having a highest retention time. That means it is staying in the system or inside that stationary phase longer time. So retention time means how long does it hold inside that column, or how hard it is to go out. The harder it is go out, the higher is the retention time. 1 or 2 less. Which one is less polar? If it is a non-polar stationary phase, right? So 1 or 2, which one is the less polar? Remember, like dissolves like. We remember that like dissolves like. So if it is a non-polar and the 1 or 2 triglyceride, which one is also less polar, what will happen then? Non-polar will stay in non-polar longer, right? So triglyceride 2 will stay longer, or it stayed longer. That means it came out late. Let's say it's 14 minutes. It came out, so it stayed 2 minutes, so 2.5 minutes longer. So it is much more polar, non-polar. It's much more non-polar than 1. All right, lactose, which is structure formula shown below, consists 2 linkage, 6 carbon sugar molecule, glucose and galactose. So state the name given to the carbohydrate that consists of 2 linkage sugar molecule. What are the name the linkage, the joint, name the type of reaction. So state the name given to the carbohydrate that consists 2 linked sugar molecule. What will be the name this molecule when it becomes 2 of them together? We know that this is a lactose. We know this is lactose, but what is the general name for this when there are 2 of them together? So it is a disaccharide. The name is disaccharide, and it is lactose because it's specifically or very precisely we know that this is what molecule. But if it was a 5, if it were, let's say, this is okay, so if it were linked in this way, oh, 1 2 3 let's say it was linked in this way somehow. So it would be the different name. It could be other thing, but it is still disaccharide because two saccharide are together, right? And this is a glycosidic linkage. This is glycosidic linkage. And the linkage is ether linkage or glycosidic linkage as well, we can say. And of course, it has to be condensation reaction. So water molecule was removed from here, condensation reaction in this way. Right, so enzyme lactose is able to convert all, functional groups is quite easy. These two are the functional group always on protein. These two will be the functional group all the time. So yeah, I think it is pretty same actually. I don't think that I have any other things to talk. Okay. And for this last question, I'll go through that. The last question is asking the absorption series. Okay, a shellfish from lives in polluted water is able to accumulate the heavy metals such as lead. So in the water, from where we are catching the fish, the seafood, right? The seafood that we are catching from our water resources or marine lives. So this is important actually. By the marine animals, they can bioaccumulate. Bioaccumulate means in their body, these heavy metals are carcinogenic, and there are a lot of researches and studies on heavy metals going on. And the study found that it is quite carcinogenic, and it is stayed long time in our body, and then it produces cancer. So that is another thing, that we are polluting our water bodies, not only our lakes or our rivers, but now the pollution has reached to the sea. Even the sea is polluted, right? So the marine life, it is coming from those water bodies. They are having all those things bioaccumulated in their body, and by turn, it is ending up in our body as well, human. So the interesting thing is, we are trying to produce many different products, making our life better, and then enjoying a lot of the blessing of our research and our science. But the thing is, it is ending up in our body, and to prevent that one, we are again taking medicine. So I don't think it is a very smart idea, right? So anyway, so not only to this the heavy metals, nowadays the plastic is also important. Now it is also problematic. Now it is a very much polluting material. The small plastic, that is microplastic, that is called, it does not get degraded in the water or a long time, thousands of years it will stay there, and the fish and all the mariners, they're eating it, and later on we are eating the fish, it is going our body. You will say that, okay, fish is eating, it is in their stomach, we don't eat the fish's stomach. No, that microplastic is so small, it is going into the flesh of the fish or any other marine animal, and then it's going to our flesh as well. So there was a research came out a few days ago, I think a few months ago. It said that every day human being, we are eating in 1 week or 1 week or 1 month, something like that, that one credit card type of plastic we are eating. So much pollution we have created in the sea. Okay, Enough. Now the problem says that an experiment was carried out to determine the percentage of lead in a particular batch of fish, and one of the shellfish was removed from its shell and chopped finely. Okay, you have to cut it nicely, and a 2.4 gram sample was heated with 10 milliliter of nitric acid. 2.5 gram of sample of that fish sample was heated with 10 milliliter of nitric acid to make the heavy metal come out from the flesh. Okay, just to extract the heavy metals to come out, we need nitric acid, and the mixture was then further diluted to 100 milliliter. All right, the mixture was diluted to 100 milliliter. So, but remember that all 10 milliliter, all 2.4 gram of the fish is in 10 milliliter. And then this 10 milliliter is in turn is in 100 milliliter. Okay. In a flask, the solution was then analyzed using atomic absorption spectroscopy and found to have absorbance of 1.20. Right. So if the absorbance is 1.20, it is about here. I try my best to draw a straight line. 1.20, and then we'll draw. Okay. Yep. All right. So we are getting absorbance at 2.8 concentration of lead, and this is quite big, right? 2.8, or let's say 2 point something. Yeah, 2.8, around 2.8. We are getting 2.8 milligram per liter of lead in that fish sample. Use the calibration curve, find the concentration of lead in milligram per, so it's 2.8, around 2.8. If somebody says 2.7, 2.9, should be okay. So calculate the percentage by mass of lead in the cell fish. So the concentration of lead in the fish sample should be that, okay, let's say we got 2.8 milligram per liter, that means 2.8 ppm, right? And it is in 100 milliliter. We have to bring it to the 100 milliliter because it was in 100 milliliter. All thing was, although it says diluted, but all thing in 100 milliliter we have. And same, this question is not telling that how much was taken. So we consider all 100 milliliter was taken. So 2.8 ppm, milligram per liter, milligram per liter, 1 liter, and it is, we have just 100 milliliters, so this is 0.1 liter, right? So it will be 0.28 milligram, 0.28 milligram in the concentration in that. So what will be the percentage? But it is asking us the percentage by mass. 0.28 in how many gram of 0.28 milligram in how many grams? We took 2.4 gram of fish, right? 2.4 gram of fish. So it is 2.4 gram. But now it is a milligram and it is in gram. So either one, I have to convert either milligram to gram or to gram to milligram. Either one you can do. Since it is okay, let me just convert to gram to milligram is, oh sorry, milligram to gram. So 10 power negative third gram is actually a milligram, right? So yeah, it will be not here anymore. So 10 power negative third gram over gram. So from there we will find, I don't know what will be the calculation, but this is the amount weight by weight. and percentage weight by weight is times 100%. Times 100% is the percentage. If only weight by weight, then I know how much gram of lead per gram of fish. But percentage, it is much easier to explain the percentage. So by this way, we can find what will be. You can do the calculation thing and then find out. This will be the percentage by weight percentage of lead in the fish. So let me just do it quickly. 2.8 times 10 power negative third over 2.4 gram is 0.001. 0.0012 percentage. Okay, so 0.0012 percentage of lead in the fish that we have. So now we have to check whether it is safe to consume that type of fish which has this much of lead in it. And the World Health Organization should have a chart that how much percentage of lead should be okay to consume. Okay, so yeah, this is how we can actually we can find it. All right, so this is the thing actually, and this is the last question we had. Is there any question that you want to ask or anything that you want to bring up? No? Everybody okay, right? All right, so this is the last question or last class I had with you, interaction. But once again, I'm telling you that I am available. I'm available